All right, we got the second half of the section today, sum and difference identities. Sum, getting it bigger here. Sum and difference identities should be a pretty short video. Look at the second slide here. You need to make sure you write these down on your piece of paper that you're going to get to use on your test on Friday. Make sure you have those. These are called sum and difference. The first one is sign. And notice the signs here. One's the first time through is a sign with addition right there. Also addition here. The second one with the red sign of subtraction. So there are really two identities right there. Same thing with the cosine. Cosine u plus v is cosine u cosine v minus sine u sine v. And then they change it to minus in here. But it becomes plus out there. Cosine u cosine v plus sine u sine v. And lastly, there are actually two tangent ones here. Tangent of u plus v, I like to say this, tan plus tan over 1 minus tan tan. Or if it's tangent minus v, it'd be tan minus tan over 1 plus tan tan. 6 identities here. Looks like there's 3. There's really 6. One for addition, one for subtraction. Make sure you get those down. You may want to write them all. Write each one separately instead of together. But make sure you get those on your same piece of paper so you can be ready to use it on Friday. All right, here's what we're going to do. It says first one says find tangent, the exact value of tangent 15. So what I've got to do is figure out some way to write tangent so that equals 45 degrees with either addition or subtraction. So what I'm going to do, because I don't know what tangent 15 is exactly, and if I punch it in my calculator, it's not going to tell me the exact answer. It's going to give me a decimal. So I'm going to rewrite it with stuff we know. Like, for example, we know the 45s and we know the 30s. So I'm going to rewrite 15 like 45 minus 30, tangent of 45 minus 30. And then I'm going to use the identity you just saw, which is tan minus tan over 1 plus tan tan. So it's going to look like this. Tangent 45 minus tangent 30 over 1 plus tangent 45 times tangent 30. Now, here's one bad thing about this, I guess. You do have to know what the values are. Like tangent 45, that's 1. Tangent 30, which is really a pi over 6, that's square root of 3 over 3. On my denominator, I have 1 minus 1 times square root of 3 over 3. And when I'm looking at that right there, actually it's 1 plus. I was about to say that's going to be cancel each other out. So on the top I have this, 1 minus square root of 3 over 3. On the bottom I have 1 plus square root of 3 over 3. One thing I don't like is the fraction in a fraction. The way you can get rid of that is multiply the top and bottom, the numerator and denominator, by the least common denominator, which is 3. So if I do that and I distribute the 3, I get 3 minus the square root of 3 because that 3 and that 3 cancel. On the bottom, I get 3 times 1, and also that 3 cancel, so 3 plus the square root of 3. And I'd be done, except, you can't leave the radical in the denominator. So what I'm going to do is multiply by the conjugate. The conjugate of 3 plus the square root of 3 is 3 minus the square root of 3. That's what I'm multiplying by. My denominator is pretty easy to do. Remember when you multiply conjugates, just do first last. So I'm doing 3 times 3, which is 9. I'm doing a square root of 3, which is 3. So my denominator, when I get done here, is just 6. The numerator, I'm really doing this times this. So I can either do FOIL, or it's really the same thing. So if you want to square it, just square it. I'll go ahead and do FOIL, though. First, outer, inner, and last. Those are all 3s, by the way. Okay, so what I have now, I can add the 9 and 3 on the top. That's 12. I can also do the minus 3 on 3, minus 3 on 3, and get minus 6 on 3. And golly bum, I would be done again, except I can cancel these 6 on the bottom with the stuff on the top. So 6 goes into 12 2 times, 6 goes into 6 1 time. And finally, I have an answer right there. That's as simple as I can get it. That problem is really not that bad. What made it bad was all the radical stuff. It wasn't what we're doing today. It wasn't the setup, which is what I'm trying to teach you today. It was dealing with the radicals, which, to be honest, it's a pretty good review for you. So hopefully that wasn't too bad. 2 more here. All right. This one says assume that sine x is 2/3 and sine y is 1/3, and that x and y are in the first quadrant, which means they're both positive. Evaluate sine of x plus y. So I'm going to go back, look at my paper there. Let's see what sine x plus y equals. It's an identity. You can use it on your test. No excuses here. Just got to bring it with you. So what it says is it's sine x cosine y plus cosine x sine y. All right, here's what I know. I know what sine x is. Sine x is 2/3. I know that part. I don't know what cosine y is. Sine y is 1/3. I know that one. What I don't know is what cosine x is. And because I don't know what cosine y and cosine x are, I've got to go through and find out what they are. So what I'm going to do is I'm going to move this down just a little bit. And I'm actually going to do the triangle thing. I'm going to try to find those values using our SOHCAHTOA. So it says sine x, so I'm going to put the x right here. Sine is opposite over hypotenuse. So if I do Pythagorean theorem, just keep this short, it'd be 9, 3 squared minus 2 squared, 9 minus 4. That'd be square root of 5 right there. And if I do the other triangle for the y, all right, again, sine is opposite over hypotenuse. If I do 9 minus 1, that's square root of 8. 8 breaks down to 2 on 2. Okay, so cosine y right here is 2 on 2 over 3. So I have this. Sine x was this. Cosine y is adjacent over hypotenuse, which is 2 on 2 over 3. Cosine x, which is this triangle, so it'd be square root of 5 over 3 times 1/3. And that would lead me to this right here. It would lead me straight to, just multiplying those out, it'd be 4 on 2 over 9. This here is also over 9, but it'd be square root of 5 times 1, which is just square root of 5. So I'm going to leave my answer like that. If you look in the back of the book, it may not look exactly like that, but that's a good way to go. Again, a lot of trig there. But again, setting it up is easy. It's just a matter of working it out, getting here, using what we used to do with the triangles to get your other values. All right, just got to hang in there. One more slide. All right, simplify. Cosine x plus cosine y minus cosine x minus minus y. So what I'm looking for here is my cosine addition. You have it written down. Cosine of x plus y. Cosine of x plus y is cosine x cosine y minus sine x sine y. Now all that is right there is just that identity. Right? Now I've got to do the second part. I've got to do minus and do the second part. So I'm going to do minus sign. And I'm going to put a big bracket here because everything in here is going to be minus. So the minus sign goes for everything. And cosine x minus cosine y is this right here. Cosine x cosine y plus sine x sine y. All right, now this is going to be the quickest one of the day. This is what I have out here. Cosine x cosine y minus sine x sine y. Now watch what happens here. This minus sign changes the sign of everything in there. So I have minus cosine x cosine y minus sine x sine y. And what I notice is this and this, those two terms, are opposites of each other. So they're out of here. They're gone. The second thing I notice is if you look at this and this, they're really the same. They're both negative. So I'm just going to add them together and get negative 2 sine x sine y. And guys, that's it. That's as far as you can simplify it. That's all you can do. All right. I know that probably quite a bit for a video, but it will be here. This would be a great one to go back and watch after you do some of these in class tomorrow. I think it'd help you a lot to do that, but that's just a suggestion. That's a good suggestion, though. So I'll see you tomorrow. We'll work on some of these. Can't wait. See you then.